Hello, this is Darren Pulsifer, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, Increasing Data Protection with Confidential Computing, with special guest host Dr. Anna Scott and guests Jesse Schrater and Ibett Acarapi.
Hello and welcome. Thank you so much for joining today on our podcast, Embracing Digital Transformation. Today we are going to go over a really important topic, and this is confidential computing. I am very fortunate in having two really qualified guests who really know this space backwards and forwards, and they're going to help us understand some of the high-level parts of confidential compute that really hopefully help us really know how does this fit in the world, how can you take advantage of it, and why is it a really important capability. So I would like to do some quick introductions, and so Jesse, if we could start with you, and then Ibett, please just do a quick introduction, and then we'll kick it off with the first question.
Sure. I'm Jesse Schrater. I'm responsible for our go-to-market of our security technologies here at Intel, specifically focused in the data center. Confidential computing is one of my babies that I've been shepherding since the very beginning. My background is IT. I've been doing it for over 30 years. I actually started my career in the highly classified Air Force intelligence systems, and so that has rolled through in here into Intel, and excited about the technologies we had to talk about today.
Beautiful. And Ibett.
Yes, hello, I'm Ibett, and I've been, now I'm the cloud security lead for America, so we're covering all the America sector, and we talk about security, and we go deep dive into confidential computing. And my previous experience in security has been both at Intel, working in the client sector, as well as a cloud solutions architect, and now as expanding that role, more focused in security and some of AI, which is a very exciting sector as well.
Perfect. Good. Well, welcome to you both. We're really excited to have you. So just in case the folks that are listening don't have a really good understanding of what we mean by confidential computing, Ibett, I was hoping you could just give a kind of a high-level overview so folks know what we mean by that.
Yeah, this is my favorite question because confidential computing has been around for a while, and it has expanded, and it has developed into different capabilities and different architectures. So beginning, from the beginning, we look at data that is being protected at rest, then in transit, and confidential computing really is protecting data in use, bringing the whole secure cycle when you're using the data. And then I like the definition because then it's how is it being defined, is how it's being architected, and the solutions and technologies that's it offering in the different sectors, right? So according to the Confidential Computing Consortium, the definition is it protects data in use by performing computation in a hardware-based, attested, trusted execution environment. And I think many would know it's like, okay, we're performing computation in a hardware-based, attested, trusted execution environment. But as I'm trying to wrap my head around, like, what does it really do? Well, the trusted execution environments are the isolated environments, which prevent unauthorized access or modification of application and data while it's in use. So with this definition, and I'm really excited about this because I had the privilege to actually work with our awesome team at Intel, who collaborated with Microsoft Azure when we were bringing SGX, confidential computing, to their customers. And this was even before Confidential Computing Consortium was formed. So after Confidential Computing Consortium came in, I was excited about it because now we have tech leaders, big technology and collaboration that are coming together as hardware vendors, cloud providers, and software developers to accelerate the adoption of the trusted execution environment and how it can actually help in the technologies and capabilities in the security sector. So if we think about it in like more familiar sector, the most familiar way that people think about it in the security practice is maybe thinking about a perimeter. So where we trust what's inside that perimeter and not what's outside. And confidential computing brings the parameter down to the virtual machine level. So depending on what architecture you're looking for, depending, what that definition is, for example, bringing down that parameter is what we recently announced, which is Intel TDX, which is now in preview in Azure. So that's down to the parameter level in the virtual machine. But then we can also do single application, where only the application is being trusted to access the data to that granular level, and that's Intel SGX. So that's kind of the high level of the architecture and the different levels on what you can actually bring to that parameter level.
Perfect. And Jesse, anything to add to that?
Well, I would just say, the big value here is you know if you air gap your systems, you'll definitely reduce your risk, but you're also going to limit your efficiency and your insights that you can get out of the data. And confidential computing is definitely another layer of security, another layer of protection that can reduce risk. But it's really more about data transformation. It's about being able to get access and leverage the kind of the full capabilities of your data assets, even when they are sensitive data, and even when the processing may be happening in on infrastructure that you don't have direct control over, or that is in an otherwise more potentially compromised arena. So it's confidential computing is about getting the values out of cloud computing, edge computing, multi-party compute, even though you've got data that may be regulated or otherwise, proprietary IP, and have levels of sensitivity. One other big advantage of leveraging confidential computing is the protection against malicious insiders. And sometimes they're malicious insiders, and sometimes they're innocently making mistakes. But cloud admins, sysadmins who have elevated privileges could potentially be a source of additional risk, where they could bypass the traditional authentication and authorization controls. And so confidential computing basically weeds all of that type of privileged access out, and so that you cannot leverage that to get access to the data. And that's a powerful implication, especially with many of the breaches we've seen lately that have been in the news with the U.S. government and military and things like that. Being able to minimize who can get access to that data and kind of weed out the whole sysadmin arena and the whole cloud stack and malware arena is a really powerful concept.
So is there a difference between controlled access and privileged access?
Yeah, absolutely. So, I mean, the whole security arena is set up around controlling access, and we have lots of systems and policies and procedures and tools in place that are all around identifying who should have access to the data and when and from where. And that's a continuing art that's always expanding within IT overall. But there's sort of this dirty secret or this difficult area on the side, which is privileged access. And if you can get admin or root permissions to a system, you may be able to get your hands on keys or on the data that's sitting in memory in an exposed state. And that can basically bypass all of the rest of the permissioning systems. So it's a very, it's an area that's kind of ripe for attack these days. We've been long encrypting data when it's in storage, long encrypting data when we send it over the network. But while we're processing it actively in memory, it's in the clear. It's typically in an unencrypted state. And so those with privileged access who could get their hands on it, either, like I said, through malware or some other direct access, can potentially see that data in its unencrypted form without the protections that would normally be afforded by authentication and authorization.
That's huge then. Why is that so important on cloud to be able to use something like confidential compute? Because it sounds like we're definitely not restricted to being able to use that type of data protection. That, from Jesse, what you were just saying, but I know within Intel, and it's confidential compute is pretty much synonymous with cloud. So, Ibett, can you maybe go into a little bit of detail about why that's so and why that's so important in that environment?
Yeah, I think it comes to the trust issues, right? Where it's like, oh, you're giving your data to the cloud, and most people are like, well, I'm going to the cloud. I'm not gonna be losing control of that data. But really, with
Hmm.
confidential computing and with the different, virtual machine and application level, you can still migrate to the cloud, and you can still have that trust boundary, and you can still be able to confidently be able to have control of your data even when you're migrating to the cloud. So I think it's kind of having
Yeah,
bringing
which
that
is
back,
huge.
like how much am I, yes, how much am I leaving, because data is very sensitive. But with confidential computing, you have that control of your data. You are able to still be the owner of that data, and also isolated from other places where you have to interact in the cloud and not have to expose your data to, or any sensitive data to any parts of the stack.
Hmm.
Yeah, I'll just add there are plenty of usages of confidential computing that involve on-prem and things like that. It's
Hmm.
not just a cloud arena, but cloud really drives home one of the big values, which is fundamentally when I'm using the cloud, I have a workload, I have data that's mine,
Hmm.
and yet it's going to reside on somebody else's system, right? That system is
Right.
provided by a cloud service provider. They are the ultimate controllers of that system. It's their data center. They've got admins, they've got a host stack that supports my instances. And so, by definition, I've got a set of things, and I'm having to rely on somebody else who I don't know to provide those extra protections and controls. One of the things I've heard confidential computing referred to as is make the public cloud your private cloud, right? Or
Oh,
run a
nice.
private cloud
Hmm.
inside the public cloud. Because
Hmm.
essentially what it's doing is it's putting the control at the data level. And I'm saying I am controlling my data, and I don't really care where it exists, because wherever it exists, they don't have access to that data. Even if they had malicious intent, they still don't have access to that data. I'm keeping
Hmm.
control of the data even as it sits somewhere else.
That's great. Could you give a real world example of how you've seen confidential compute used? I think
Yeah,
that would help drive that home.
sure. I mean, there's lots of examples out there. A couple kind of quick ones that come to mind. There's been a really interesting story in the German healthcare system, because they've been maybe one of the last in the world still keeping most of their country's patient healthcare records on paper, and
Wow.
security has been one of the big issues there, because going to a digital format could potentially also open up
Hmm.
privacy concerns, and general management concerns. And so they have now finally embarked on a project, and are actually far down the line on this project, to finally digitize all of the country's patient healthcare records, which have a lot of private data in them, obviously, and are under a
Hmm.
lot of regulation and controls on that. And they're using confidential computing in the cloud to provide a technological control over that data, so that just as I
Nice. Okay.
described, even as that data sits in a cloud, the cloud admins and the cloud stack and any potential vulnerabilities that come into play within the cloud are still not going to be able to get access to that data. So it's providing additional risk protections on something that is very sensitive and very important to keep private. That's a great example of sort of the cloud side of it. We've also seen, though, in the arena of just protecting secrets, and especially in edge compute arenas, a very large global social media company that I won't name, but you know them. They have basically content delivery network all over the world, and that means they have to run systems that sit at the edge for them in little data centers, um, uh, uh, telecoms, etc., all over the world. And yet they have keying and encryption and management protocols and uh, you know private AI and a lot of things that run to manage that control plane. And that's sensitive IP for their company. And so they're using Intel SGX to protect that management plane, even as it runs in the edge in, hundreds and hundreds of data centers all over the world that are not actually owned by them, but are being provided to them.
And I really like that
makes
example,
sense.
Jesse,
Yeah.
because this is, Intel SGX is the only technology in the industry that can provide this really small trust boundary. And, there are other ones, in different architectures, but this is really where it shines and where it's like a solution now that exists and is already helping customers.
So can you explain, because one of the things I don't understand well is I know SGX is really good about creating trusted enclaves, and that has a very small perimeter and a very small trust boundary, therefore a very small attack surface, right? But is there additional security that comes from that being a hardware security feature, as opposed to being a software a software way of creating that enclave? Is there really a differentiation there, or are those roughly equivalent? So I'm
I'll take that one. Another saying I often use is security is only as strong as the layer below it. So you can have the best application security in the world, but if you have a vulnerability in your operating system or in your hypervisor, that can potentially expose the data above it, right? Well, continue down the layers of the stack that we don't think about as much, right? Under that operating system, there's firmware running, and under that firmware, there's hardware. Each layer could potentially expose the layers above it because they have to trust those lower layers. They don't have control over them. If you keep going down the stack, you get down to the lowest layer possible, the immutable layer that doesn't change, and that's the silicon. There's nothing below it, right? And so that is the perfect place to home these core security technologies. And one of the things that's happening here is Intel SGX, Intel TDX, what they allow is for the application to basically bypass the entire system stack, bypass the OS, bypass the hypervisor, and speak directly to the chip, to instructions in the chip that manage access to memory. And so if there's a vulnerability in the OS or a vulnerability in the cloud stack, it doesn't matter because the OS and the cloud stack are not involved in the transaction. It's happening directly between the application and the hardware itself.
Okay.
And so if you were to home it anywhere else, like say you were to home this solution in your hypervisor, or you were to home it in the OS, a vulnerability below that could still expose this data. And that's why we put it all the way down in the chip. And you're seeing that from Intel as really the first to bring this capability to market on a mass scale with Intel SGX. But you're also seeing other silicon vendors and everybody basically kind of, taking that same approach. And it really is the core to the definition of what is confidential computing.
Oh, that's amazing. Thank you. That is a really good clarification. And I want to take us zero trust is all over the place today. Like with the government mandates and with the NIST standards in the public sector, we have even more force around mandates to actually say zero trust is something that's got to be applied. I know that in itself is just a massive subject, and that's not what we're going to cover today. But I do think it would be really helpful if, Ibett, could you just kind of go over and say, how does confidential compute fit into a zero trust type of architecture, and is this a valuable capability in that space?
Yeah, so we have the zero trust architecture and the zero trust strategy, right? So like before, zero trust approach to security was, a more traditional, like we look into the perimeter defensive strategy. In a perimeter defense, the organization protects the boundaries of its private network with firewalls and multi-layer and software security solutions in order to regulate and filter traffic that's coming in and out of the public networks, right? So in that traditional way, once a user or device has been verified and admitted to the private network, it is typically treated as a trusted resource. You're in, you went through all the verifications, all the different steps, you're good to go. However, now with zero trust security framework, is designed around the assumption that a cyber attack can happen at any moment, even inside, even once you're coming inside. And there is no such thing as a trusted resource. There's not how you get admitted once and you're good to go. It's actually currently continuously looking into what is being validated. So it's protecting the framework and designed to apply security, the technologies on the hardware, the software, the data, and the users across the organization's infrastructure. And each user or device must be authenticated repeatedly before every interaction. So in every different phase, and saying, well, there's no need for me to trust you or assume that there should be trust or access that you should be given. So let me have my own process in my own layer, in my own space to actually verify this. And so that's, the strategy, like as an overall zero trust strategy, how do you implement that in the capabilities and technologies that you're using? Well, you want to apply that by design and by architecture. Those technologies are already allowing you to do that, or already doing that for your architecture when you're designing in your environment. And confidential computing does that. It's already designing and building that smaller trust, right? So you don't have to be, like Jesse explained, you don't have to be trusting the OS, the cloud provider, because it's bringing the whole way of identifying and actually making sure that only certain places that need to have access to this sector would have it. So those are the two different ways that the strategy and the architecture actually come together for confidential computing.
Perfect. Yeah, and that's super helpful, right? Because the world has changed so much, and how we have to navigate this world to be able to really protect our data requires some advanced tools like the ones you guys are talking about. And I did want to kind of follow up on that a bit too, and say this one's for you, Jesse. You went into some detail around SGX, right? There are other technologies that play in this space. Can you give us just a brief overview of what those look like and a fuller landscape, right?
Yeah, confidential computing and some of the technologies such as SGX and TDX, they kind of fall into this larger bucket, which the industry calls privacy enhancing technologies, and really the whole industry is recognizing this need, and so everybody is attacking it and going after it to try to provide solutions in this space, and confidential computing is a big part of that. There are other solutions. Intel has been not just doing confidential computing, but also contributing towards the standards and the definitions in a lot of the other spaces, including things like fully homomorphic encryption, which basically kind of addresses the problem purely from a very advanced cryptography perspective in keeping data always encrypted. And we're really excited about the revolutions in that space that are going to be coming in the years ahead and are actively contributing in that. I think what makes confidential computing and trusted execution environments unique in this overall arena, though, is that they're available broadly today in production for mainstream workloads, large scale workloads, right? It's a now thing. And they come with very little performance overhead that's measured in the, low single digit type overheads that are much easier to work into, current business processes than something that may have orders of magnitude of cryptography that has to execute and is going to need to be accelerated in the years ahead. So being able to take a native workload, even in an unchanged format, and run it within this encrypted and isolated environment, on instances that you can get from Microsoft Azure or from Google or whoever today, is really powerful.
Wow. Yeah, a lot to look for. It sounds like there's another podcast we need to do around the homomorphic encryption as well. So I will follow up with you on that.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.